Artificial intelligence is the area of computer science that tries to make machines that can replicate human intelligence, to do tasks that humans can do but have historically been very difficult for machines. That doesn't necessarily mean things that we would call intelligent in humans. We'd normally think that someone would need to be very intelligent to play chess to grandmaster level, but a computer beat the world chess champion Garry Kasparov in the 1990s. On the other hand, tasks that almost any healthy human could do effortlessly are still incredibly difficult challenges for AI, like picking up a glass of water without spilling it, or having a conversation about how your day was. In fact, having an ordinary conversation is one of the classic AI challenges, enshrined in the Turing test, invented by Alan Turing. Turing was not only one of the original inventors of the computer and responsible for breaking the Nazi codes in World War II, he also invented the basic ideas of AI. He asked himself, how would it be possible to decide if a computer was intelligent or not? His idea was based on a popular party game of the time. A woman and a man leave the room and the players can send questions to each of them on pieces of paper. They have to guess, based only on the written answers, which is the man and which is the woman. Why not play this game, but instead of a man and a woman, you have to guess between a human and a computer? Modern versions of the test involve chatting to a computer or a human via a text message interface and trying to guess which is which. No computer has managed to fool most people over a long period of time, but there are systems that have fooled people in short conversations. Although the Turing test is popular, there are flaws. First, the successful chatbots, as they're called, often use simple tricks to fool people rather than showing true intelligence. Also, there are many challenging areas of AI that aren't covered in the test, like recognizing faces, manipulating physical objects, or even driving cars. In fact, AI has split into a wide range of subfields that address particular challenges like computer vision, computers that can see and understand, natural language processing, computers that understand human language, robotics, and even computational creativity, computers that can make creative works of art. Many of these subfields have resulted in computer systems that can do some incredibly useful things. Robots that can run our factories. The Google search engine, which is based on sophisticated natural language processing. And computers that can even diagnose diseases from looking at X-ray scans. We're likely to see a lot of major advances in this type of task-specific AI in the near future. But many AI researchers regard this as narrow AI, that is good as individual tasks, but does not have the kind of general, task-independent intelligence that humans have. This artificial general intelligence is still a long way from being achievable. So how does AI work? There have been many different techniques used over the years, most with only limited success. Often they would work on simple lab problems, but fail to scale up to the complexities of the real world. Early systems were based on logical rules. For example, expert systems were a type of AI system that tried to do things that expert humans can do. For example, diagnosing a disease. In this case, there might be a rule saying that if a patient has pain in the lower abdomen, they have appendicitis. One of the big problems was that these rules are rarely certain. There are many possible reasons for a lower abdomen pain. Gradually, researchers developed ways of dealing with this uncertainty, like the mathematics of probability. And expert systems had reasonable success in several domains. But how would you create an expert system for recognizing a face? What are the rules? We humans can do it, but we don't know how we do it. Building expert systems relied on experts knowing the rules they use to make decisions, but very often they're subconscious. We don't quite know how we do things. This is one of the many reasons that most researchers started using a different approach called machine learning.